Hi everybody, how are y'all doing today? So Miss Bordelon here. We're not going to have a live session on Monday because it's Labor Day, so I wanted to do a quick little Teachlet just to kind of go over some things that you had in your lessons the past few days. So yesterday you should have done the lesson on measurements of matter and looking at the type of measurements that we do in science and about the difference between mass and weight. And then today's lesson is about volume and density, and so you're kind of taking what you learned yesterday's lesson and applying it to today's lesson. So hopefully this will help you a little bit since I won't be seeing you in live session until next Wednesday. So what I want to talk about today is just kind of mass, measurements, and density, because we have a little bit of math that's going to be put in here, which is fine. It's simple math, and of course math and science are very, very intertwined, and it's very important that you can do both of them together. It's going to be a good skill this year in doing both of those together. All right, so what I want to show you here, what I have for you first of all, is a little water bottle. And as you can see, it looks kind of strange. So I'm going to kind of just mix it up a little bit. And then what do you know this is happening? So I want y'all to be thinking at home. What kind of thing do you think is happening here? What kind of liquids do you think are inside of here? And kind of why is it doing that? Hopefully you are thinking in your mind that one of these is oil and one of them is water. We just added some food coloring just to make it look cool. So we do have the same amount of oil, same amount of water, and the reason that these two are not mixing and are separating the way that they do is because of density. And so what we're going to talk about really quickly is how or why something is more dense than something else, and kind of how would we calculate that or figure that out in science. So what I'm going to do for your viewing pleasure is I'm going to add a half of Alka-Seltzer. You guys can do this at home with parent permission if you want. Again, it's just water with food coloring, some vegetable oil, and I'm going to take a half of an Alka-Seltzer tablet, and I'm going to drop it in there. I'm not going to put the top on it, but you'll see in just a second some of the bubbles. So we have a little bit of a reaction going on in there, creating that gas, creating those gas bubbles, and it's going to start pulling up some of that red water and trapping the water droplets in those gas bubbles and bringing it up to the top. So we have kind of a little homemade lava lamp, and it's kind of hard to see, but there you go. You can kind of see some of those red droplets. So pretty cool, just little demonstration of how density works and also a chemical reaction taking place in that creation of that gas molecules, which we'll be talking about in an upcoming module next. We'll be talking more about chemical reactions. So just pretty cool to I'm just going to put it over here so you can kind of still see it. Next thing I want to talk about, guys, is the difference in mass and volume. All right, so in yesterday's lesson, you learned about mass. All right, remember mass, I'm going to write this up here. Mass is the amount of matter in an object. Amount of matter, I call that stuff. Okay, so I like to keep things pretty simple in talking about science because we don't want to make it any more difficult than it needs to be. So amount of stuff that's inside of something, or amount of matter, amount of molecules and atoms that are inside of this. So when you look at a Coke and a Diet Coke can, they're pretty similar, right? But there's actually a big difference between these. Okay, and if you're thinking at home, hopefully you're thinking that one of these has a lot of something in particular, and one of them does not, and that's what makes it Diet Coke. And so what I want to do is I just want to look at the difference in the mass. So I'm going to put, actually I did the Diet Coke last. I'm going to put the Diet Coke. Hopefully you know that this is what's called a triple beam balance, called triple beam balance because it's triple means three. There are three beams, one that measures in hundreds, one that measures in tens grams, and then one that measures in 1 grams. And remember, this is a triple beam balance. It's not a scale that you jump on at home, because a scale at home is going to give you your weight in pounds. Okay, remember, weight is the force of gravity that pulls down. Mass is different. Mass is the amount of stuff inside of something. Okay, so the mass of this Diet Coke can on Earth and the mass of the Diet Coke can on the moon is going to be the same. It's the same amount of stuff that's inside of it. So the mass of the Diet Coke is, I'm going to put DC for Diet Coke. I'm going to add, it's 300, 60, and then 5. So 365.2. Remember, that is in grams. We measure mass in grams in the metric system. All right? Now I'm going to go ahead and do the Coke can. So do y'all think it's going to be the same or different? find out. All right, obviously it's different. You can see the balance is not balanced anymore. We want those lines to meet up. So that side's heavier than this side. So what we need to do is move our scale over, push that back to 0. And when it's gone too far, we know because this side has too much weight. So I'm going to push this back. And then now I'm going to go to my 1s in the front. Just kind of slide it over until we are balanced right here. All right, so my Coke can is 385 grams. So as you can see, we do have a difference in the mass. Now, the next thing that density depends on is what's called volume. So if you look at these two cans, volume is the amount of space that something takes up. All right, so do these two cans have the same volume? Do they have the same volume? Well, let's see. They're both, this one's 12 fluid ounces, and this one is also 12 fluid ounces. So the volume is the exact same. So we have the same volume, but we have different masses. Okay, now let's talk about density. When you calculate density, what makes something more dense than something else is the amount of mass per volume, or per the space that it takes up. Right? So these both have take up the same amount of space, but we discovered that they have different masses. So we would assume that the density would be different. The way that you calculate density is equal to the mass, how much mass is in something, per the volume. Okay, so if you think about math class, when you say something per something else, that should look like a division symbol to you. So density is equal to mass divided by the volume. How much mass per volume in that same amount of space. So if we calculate the density of the Diet Coke, that would be another way you can look at this, where that I had a teacher that once taught me this. Density equals love. So it's mass over volume. You see the M over the V. So that helps you to remember our equation. So density equals mass over volume. We also like to make a density pyramid. So density equals mass over volume. And the point of this little pyramid, really, really great, I'm going to draw it again over here so you can see it a little bit better, is because we're not always going to be looking for density. Sometimes we are given the density and the problem is going to want you to calculate the mass, and I'll show you how to do that in just a second. But that's why that pyramid is so awesome. I still use it. I still write it on my papers when I'm doing that. All right, so let's find our density of our Coke. So the density of the Coke, so we're going to put our mass, 385 grams, I'm still going to include my units, over my volume, which was 12 fluid ounces. I'm just going to keep it as ounces, even though we don't use ounces in the metric system, just because I did not, well, I'll give us milliliters, actually. Just kidding. They give us the milliliters as 355 milliliters, okay? And then we're going to calculate that. So let me grab my trusty calculator, which is my phone right now. And I'm going to calculate 385 divided by 355 equals, and my answer is 1.08, and that's going to be grams per milliliter. Grams per milliliter. So I'm going to carry my units and keep my units. Hopefully you guys can see that okay. All right, now, so that's my density of the Coke. And now I'm going to go ahead and do my density of the Diet Coke. So my density of the Diet Coke, I'll do that over here. Density of my Diet Coke is 365.2 grams divided by my same volume, which is 355 milliliters. All right, so my density of my Diet Coke, 365.2 divided by 355 equals 1.03. 1.03 grams per milliliter. All right, so my density of my Coke is 1.08. My density density of my Diet Coke is 1.03. So, based on those predictions, based on those measurements, which one do you think is going to sink a little bit more than the other one? Which one is going to be more dense? So density of water is 1.0. All right, so what do you think is going to happen to my Coke? That's 1.08 density, and my Diet Coke is 1.03. All right, so I'm going to go ahead, and I actually have a bucket of water right here, and I'm going to go ahead and drop them in and let you see. Okay. Okay, so you should notice that my Diet Coke is kind of sitting, sorry y'all, I'm trying to figure out the best way to show you here. It's kind of sitting on the top of the water, whereas my Coke went straight to the bottom and is resting on the bottom. So my Coke is more dense, and we figured that out from our calculations, than our Diet Coke. All right, the reason for that, my friends, is that Diet Coke doesn't have the sugar that the Coke has. So our Coke has a lot more mass because it has a lot more sugar. Sugar is more dense than the artificial sweeteners that they put in the Diet Coke. So we do see our density. We can see that right now with our Coke at the bottom of the bucket and our Diet Coke is floating. And now what I just wanted to show you is how you would use this pyramid to help you out. Okay, so I'm going to go ahead and erase some of this and make some room. So let's say we were given our density and we wanted to find the mass. So what you would do is you would take your pyramid, we are given the density and we're looking for our mass. So what we're doing is we're going to cover up the M, since that's what we're looking for. And if you notice, what we have left is the D and the V that are next to each other. Okay, think about in math class, when two numbers are right next to each other, what does that tell you to do with those numbers? We are going to multiply them, so D times V. So if we cover up the M, we have D times V. So if we're given the density and we're given the volume, we can calculate for the mass. All right? Same thing if we're looking for volume. Let's say they give us the density and they give us the mass of something and we want to figure out the volume. What you do is take your finger, put your finger over the V, and as you can see, you are left with M over D. So to calculate volume, we're going to do M divided by D. That's going to give us our volume. So you can calculate for density, mass, or volume using the same equation. Okay, so hopefully that will help you in your lesson today, and we're going to talk more about that in live session next Wednesday. We're going to do a fun little density column next week, and I'm looking forward to seeing you all there. Have a great day.